Good morning, all of you. Today we are going to start about the new lesson, that is about the Unit 6 Solid State. Unit 6 Solid State, the first volume, page number 176. Solid State. Here, this unit, what we are going to learn, what is our learning objectives? To learn about describe the general characteristics of solid, and one more point, distinguish amorphous and crystalline solid. These are the two important learning objectives. Before that, we have to discuss something about the introduction of solid. Here, all of you know about the matter. The matter may exist in three different states. Am I right? Three different states. One is about that solid, another one is about the liquid, and another is about the gas. We know that solid is differ from liquid and gases because solid has definite volume and definite shape. Am I right? Each solid have a definite volume and also having a definite shape. Here in the solid, the atoms or molecule or ion, they are tightly held in an ordered arrangement. Here, the solid having some of the ion, or it may be in some molecules, or it may be in atoms. They are closely packed. Otherwise, we can be say tightly held in an ordered management. There are many types of solid. Many types of solid. We know that one: a bench, a desk, wood, plastic, some of the metals, diamond, the ornaments. We know that one. These are all solid state. Am I right? But we record solid with different properties, and also some have some various applications. Here, what we are going about this lesson, the solid state lesson, what is we are going to learn means we have to learn about what are the characteristics of solid. That is our learning objectives. How to learn the characteristics of solid and about some of the classifications of solid, some of the structure of solid, and some of the properties of solid we have to discuss. And one more, we have to need one clear idea about that crystal defect. And one of the very important about this lesson, crystal defect, and about their significance. Crystal defects means all of you know that one, some of the molecule having some of the defect means some of the, that means short key defect. I will explain later, okay, about the short key defect. What is about the short key defect means? Here in one of the crystals, some of the ions are missing. That is, ions means positive ions and negative ions. That is, we are saying cation and anion. Okay, there is missing of equal number of cation and anion. Equal number of cation. Sometimes one cation and one anions are missing. That we are saying a short key defect. Okay, don't forget that. And the example is about the sodium chloride. And another one defect we have to discuss about that fungal defect. Fungal defect. F-R-E-N-K-E-L. Fungal defect. That we can be say displaced atom. Otherwise, we can be say dislocation of an atom. That means the ion which is missing from the lattice point occupies an interstitial position. That is displaced atom. We can be say that on a fungal defect. And about one more, I think that two more defect having. One is about that metal excess defect. That is about that the metal excess defect is arise due to the presence of more number of metals. We are saying metal excess defect. And one more point we discuss about that metal deficiency defect, metal deficiency. That is, it is due to the presence of less number of cation than the anion. These are some of the crystal defects. Okay, so we have to learn this area. Anyway, today we have to learn about that the general characteristics of solid. What are the general characteristics of solids? One of the very important 3-mark question. Okay, one of the very important 3-mark question. I think that our textbook having 5 points. We have to learn the 5 points for the 3-mark question. Okay, first one, what are the, we know that one general characteristics of solid. Already we learned the small class. First point, anyhow we have to discuss about the first point. A solid have definite volume, otherwise we can be say a definite mass and also a shape. Solid have a definite volume and also a definite shape. What's the first point, my dear children? Solid have definite volume and shape. This is the about the first point. Second point, the solid are rigid and incompressible. All of you know that one. Solids are rigid and incompressible. Third point, solid have strong cohesive force. Cohesive force means we know that one. Solids are very hard. Am I right? It is a hard, and this means here the atoms or ions or molecules are sticking together. That we are saying cohesive force. Am I right? The fourth point, solid have a short inter-atomic and also ionic or molecular distance. A solid have short inter-atomic, ionic or molecular distance. One more point you have to discuss. Here, the solid means it contains some of the ions, atoms or molecules. Am I right? They are constituent. That we are saying ions, atoms or molecules. We are saying constituent. They are constituent have fixed position, and they can oscillate about their mean position. Why it is means due to the intermolecular force of attraction. Here, this property, that means this intermolecular force of attraction not having the liquid and gas. Solid only possess an intermolecular force of an attraction. These are some characteristics of solid. Next, we can be discuss about what are the classification of solid. What are the classification? The classification of solid is broadly classified into two types. One is about that crystalline solid. Another one is about that amorphous solid. Crystalline solid means all of you know that one. Our house also having some crystalline solid. Am I right? Maybe just like sodium chloride, sugar. These are all just like crystals. Am I right? The formation of crystals. So crystalline solid, all of you know that one. Crystalline solid. And about that amorphous solid. What is about the amorphous solid means some glass materials, glasses, rubbers. These are all about the amorphous solid. Here, one more point is about that crystalline solid means the crystalline solid have a regular shape. They have a definite structure. One of the very important, they have a regular shape. They have some shape. Crystalline solid have some regular shape, and they have a definite structure about the crystalline solid. What is about an amorphous solid? Here the atoms and the molecules are randomly arranged. Okay, randomly arranged. This here amorphous solid. Here having the atoms or molecules are randomly arranged. It have a irregular pattern. It is not a correct pattern, one of an irregular pattern. Anyhow, the crystalline solid again classified into 5 types. Again classified into 5 types is number 1. Yet about that ionic crystal. Number 2, covalent crystal. Number 3, molecular crystal. Number 4, metallic crystal. Number 5, atomic solid. One of the important term, atomic solid. Can you understand, my dear children? Here the classification of solid, they are again classified into 2 types. One is about that crystalline solid. Okay, it possesses a regular shape. Am I right? Crystalline solid have a regular shape. Suppose in our house having the salt, am I right? That is sodium chloride salt. They have a big size salt. Am I right? Suppose they have, if you are taking one salt, means they have some regular shape, that we are saying crystalline solid. About the amorphous solid means we know that one about the glass, rubbers. Okay, here the atoms and that ions or molecules are arranged randomly. Am I right? Next about the crystalline solid. Crystalline solid means again it is classified into 5 types. One is about that ionic crystals. That ionic crystals means example sodium chloride, potassium chloride. These are all some example. Sodium chloride, NaCl, potassium chloride, some example. Second one is about the covalent crystal. Covalent crystal means all of you know that one, silica, SiO2, silica, diamond. All of you know that one. Already we discussed about the diamond. The third one is about the molecular crystal. Molecular crystals, one of an examples we are given some hydrocarbon. What is about the hydrocarbon? Carbon and hydrogen. Simply we are saying carbon and hydrogen are called as hydrocarbon. Here one of an example is about that naphthalene. It is the molecular formula C10H8. Naphthalene, molecular formula C10H8. Anthracene means the molecular formula C14H10. Am I right? C14H10. And one more about the glucose. All of you know that one. C6H12O6. These are some examples. Next about the metallic crystals. In the periodic classification, all of you know that one. Some of the metallic elements. Means sodium, magnesium, silver, copper, gold, gold, etc. These are all some of the metallic crystals. Next about that atomic solid. Atomic solid means one of the frozen element. Frozen element means about the group 18. That means the frozen means nothing but it is about the conversion of solid into liquid, that we are saying about the frozen element. Am I right? These are some classifications of solid. One more, we have to classify the solid into 2 major types. One is about that it is this type is based on the arrangement of their constituent. One is about the crystalline solid, and another one is about that amorphous solid. Okay, here we know that the term crystals, this comes from Greek words that kristallos, which means they are saying a clear ice. Okay, clear ice. These are all about the classification of solid. Here one of the very important one important point about that. The crystalline solid, that means here it is one of in which it constituent, that constituent means whether it may be in molecules or ions or atoms. Here these patterns are arranged in an orderly arrangement. The orderly arrangement extends over a long range. That means what we can be say, the arrangement of atoms or ions or molecule. So a repetition, that is repeat, the process is repeat in a particular distance. On a particular distance, the arrangement of atoms or molecules show their repetition in a particular distance. That's we are saying about that long range order, right? Long range order. Okay, the arrangement of such a type of a constituent in crystalline solid is such the potential energy of the system is at minimum. The arrangement of this is one of the one-word point. The arrangement of such a constituent, that is atoms or molecules or ion in a crystalline solid, is such that the potential energy, some of the potential energy of a system is at in minimum. Okay, minimum. Next, we can be discuss one of the very important point, one of the very important question about the one of the 3-mark question. What are the differences between crystalline solid and about the amorphous solid? What are the differences between crystalline and amorphous solid? First one, crystalline solid. We can be say first point, long range order. Otherwise we can be say long range orderly arrangement of atoms or molecules or ions. That we can be simply say constituent. Long range orderly arrangement of constituent. Okay, that means what is about that one? What is the meaning here? The arrangement of atoms or ions or molecules or repetition it in a one of the particular distance, that we are seeing long range order. But what is about the amorphous solid? Amorphous solid means here not a long range order, here having short range. Here there is no repetition properties. Okay, there is no repetition properties. Here the atoms or molecules are arranged in a random, can be say random arrangement of constituent. So first point, don't forget that long range order is here, amorphous about the short range order. Okay, second point, here crystalline solid, all of you know that one, it have a definite shape, okay, because we know that one, some crystalline solid, they have a definite shape. Am I right? What about the amorphous solid means it have a no definite shape. Okay, no definite shape. We can be say irregular shape. Which shape, my dear children? Irregular. Okay, irregular shape. Next, third point. Here, crystalline solids are anisotropic in nature. What is about that means? Anisotropic means a substance having a physical properties which has a different value. Okay, different value when we measured in different direction. Some of the substance, the physical property, some of the physical property means we can be say thermal conductivity, refractive index, electrical conductance. These are all some of the physical properties. I'm right. Here, the substance having a physical properties which has a different value when measured in different direction. I think that we have more point we can be discussed the next class about the anisotropy. Next about isotropic. Here the isotropic means tell about that same value, that is measured, we get same value. Okay, that is about that. They are isotropic like liquid. Okay, like liquid. Next, about that fourth point, they are true solution. True solution. Here, crystalline solid are considered as a true solution. What's the opposite of true? Pseudo solid. Am I right? Pseudo. Otherwise, we can be say super cooled liquid. They are considered as pseudo solid. Otherwise, super cooled liquid. Next, about a definite heat of fusion. Crystalline solid have a definite heat of fusion. Amorphous, not definite heat of fusion. Not definite heat of fusion. Here, crystalline solid, they have sharp melting point. Sharp melting point. Okay. Here, what about this amorphous means? When we are heating amorphous solid, the temperature is increases and increases. Okay, when the temperature is increases and increases, then the substance becomes softened. Okay, softened. Okay, generally we can be right, softened over a range temperature. Okay, over a range temperature. Here some of the example we can be used about that diamond, sodium chloride, potassium chloride. These are all some examples about crystalline solid. And amorphous means we can be say a glass, a plastic, a rubber. These are all some example. Okay. So the remaining portion we can be discussed next class. My dear children, from the, I think about that the first, sorry, if not first lesson, I think about the second lesson. Second lesson, the three book back questions. I'm not explained about that three book back question. I think that the page number, please all of you turn over the page number. Page number is 55. Page number 55. Question number 16, 17 and 18. Question number 16, 17 and 18. These three questions you have to discuss. So first question, a hydride of, what is about that? Hydride of second period alkali metal. A hydride of second period alkali metal. Aeon reduction with compound of boron to give a reducing agent is C. One of the problem, identify A, B and C. This is our question. Here, a hydride of second period alkali metal A. Second period alkali metal A means alkali metal. A hydride means all of you know that term, hydrogen. Second period alkali means all of you know that one. This is about the lithium. We are telling about the lithium hydride. So we know that one. A means lithium hydride. Okay. Here lithium hydride A, one of the compound lithium hydride A on reaction with the compound B, that is about the boron compound. Boron compound, already we learned thoroughly about the boron compound. That is about that diborane. Am I right? Diborane. What is the formula of diborane? B2H6, diborane. That is about that boron compound. This boron compound which give an reducing agent is C. One of the very good reducing agent, all of you know that one. One of the very good reducing agent is lithium borohydride. Lithium borohydride, that is about that LiBH4. LiBH4. This is about that problem we have to discuss. So one by one we can be discussed. So all of you know that one. The first one A is what? First means lithium hydride, that is hydride of second period alkali metal. Second period alkali metal, that is about that lithium hydride. A means what? lithium hydride. This lithium hydride reacts with boron compounds. That is a diboron in our textbook having diboron, that is B. What is the formula of B? Diboron B2H6. So I am going to write the equation LiH, that is lithium hydride, on reacts with B2H6. What's the name of the compound? Diboron. In the presence of ether, we get one of the compound that is called lithium borohydride. The formula LiBH4. LiBH4. Okay, LiBH4. So how can you balance the equation? In the reactant side, diboron, that is B2, 2 boron having, so the product side also make it 2. So 2LiBH4. So how much lithium is there? The product side 2. So make it the reactant side also 2. Now the equation is balanced. So we have to write the name of the compound. We have to make on tabular column. First, we have to write the compound A, B and C. Compound A, B and C. Compound A means, we know already, we discussed lithium hydride. LiH, lithium hydride. So what's the name of the compound? Lithium hydride. You have to write name. You have to make it one of the tabular form. One is about the compound. Second one is about the formula. Third one is about the name. Okay, 3. We can be write one more tabular column, like we can be write the serial number. Okay, there is serial number. First we have to write the serial number, ESL number. First one, that is about that one we can select one, that is compound A, compound B, compound C, 1 2 3 like that. Second about that B, boron compound. What is that one? B2H6. What is about the B2H6 name? Diboron. Next about C, formula LiBH4. So one of the reducing agent we get, that is which reducing agent? Lithium borohydride. So I have to write the name lithium borohydride. This is the question number 16. The question number 17. A double salt which contain fourth period alkali metal A on heating at 500 Kelvin gives B. Aqueous solution of B gives white precipitate and gives a red color compound with alizarin. Identify A and B. Here, double salt. All of you know about that double salt. What is about the double salt? Many times we discussed that one. Double salt. Double salt means we can simply say potash alum. Am I right? Potash alum. That is about what? Double salt. So that already we know that one. Double salt. Potash alum. So what is the formula of potash alum? K2SO4 Al2SO4 thrice 24H2O. Once again, please tell that formula. K2SO4 Al2SO4 thrice 24H2O. This is what? Potash alum. Okay. Anyhow, this potash alum on heating at 500 Kelvin, here the 24 water molecules is removed. Okay, the 24 water molecule is removed. So we get another alum called band alum. That is compound B. So compound A means what? Potash alum. Compound B means what? Band alum. Can you understand, my dear children? So how to write down tabular column. First you have to write serial number. Second column you have to write compound. Third formula. Fourth name. So serial number 1, that is compound A. What's the formula of potash alum? K2SO4 dot Al2SO4 thrice dot 24H2O. What's the name of the compound? Potash alum. Potash alum. Second one, serial number 2. It's a compound B. What's the formula? K2SO4 Al2SO4 thrice. Al2SO4 thrice. What's the name? Band alum. Band alum. Dear children, one more point in our textbook. Here the aqueous solution of B gives white precipitate with barium chloride and gives a red color compound with alizarin. Identify A and B. Here in aqueous solution of band alum means that about that what's the formula here? Potassium sulfate and also aluminum sulfate. So this band alum contains potassium ion, sulfate ion, aluminum ion. Am I right? So here the sulfate ion reacts with barium chloride. Barium chloride. Okay, this sulfate ion reacts with the barium chloride. We get a white precipitate of barium sulfate radicals. Barium sulfate ions. Barium sulfate. So how to write the equation? Barium chloride. Barium chloride. Barium chloride, potash alum, that is sulfate radicals on reacting SO4 2 minus ion gives barium combines with the sulfate. Barium combines sulfate to form barium sulfate, and also we get chloride ion Cl minus. That is, can be right 2Cl minus. Equation is balanced. Next, here the band alum, and another one more ion is present. That is about the aluminium. This aluminium ion reacts with alizarin solution. We get a red colored compound. Red colored compound. Next, our textbook, the last question. Question number 18. Question number 18. Carbon monoxide is a reducing agent. Carbon monoxide is a reducing agent. Justify with an example. Justify with an example. We know that on carbon monoxide is act as a strong reducing agent. Am I right? It's a very good strong reducing agent. Carbon monoxide is a strong reducing agent. Here carbon monoxide reduces one of a metallic oxide into metals. Metallic oxide is into metal. Here I am taking one of the metallic oxide. Means iron oxide Fe2O3. Okay, this iron oxide Fe2O3 on reacts with carbon monoxide, CO, carbon monoxide, we get Fe plus the carbon monoxide combines with oxygen. Carbon monoxide combines with oxygen, we get carbon dioxide, CO2. Then how can you balance the equation, my dear children? How can you balance the equation? The reactant side, how much ion is there? 2 ions. So make it product side 2. Am I right? Now, reactant side, how much oxygen having the ion oxide? Fe2O3. 3 oxygen. So, have to make it 3 carbon dioxide in the product side. So, 3 carbon shares come to the reactant side, 3 CO. Now, the equation is balanced. Am I right? Have any doubt? Okay. Next. I think there one more question. Our today portion, that is about that question number 8, that is page number 98, third lesson, unit 3, P block element 2, unit 3, P block element 2, question number 8. What is the question number 8? What is the hybridization of iodine in IF7? What is the hybridization of iodine in IF7? Give its structure. What is the hybridization of iodine in IF7? Give its structure. Dear children, iodine is bond with 7 fluorine. Am I right? Suppose the central atom may be iodine. I am taking iodine. This iodine is surrounded by 7 fluorine. Am I right? Fluorine 1, fluorine 2, fluorine 3, fluorine 4, fluorine 5, fluorine 6, and one more we can give fluorine 7. Okay, here. Now I am joining here fluorine, here joining, here also joining fluorine. So, as per the hybridization concept, we know that one, the number 2, that is number 2 is equal to, number 2 means SP hybridization, 3 means SP2, 4 means SP3, 5 means SP3D2, 5 means SP3D, 6 means SP3D2, 7 means SP3 D3 hybridization. Can you say, my dear children, what is a hybridization? For IF7 molecule, the hybridization of iodine in IF7 is SP3 D3 hybridization. So my question, what is my question means, how much bond pair having this molecule? How much bond pair? Can you see? 7 bond pair. How much lone pair of electron here? Any lone pair of electron? No lone pair of electron. So 7 we get. So the hybridization is sp3d3 hybridization. Next. What is our structure? That is also important. Give the structure. They have no lone pair of electron. So our expected structure is pentagonal, pentagonal, P-E-N-T-A-G-O-N-A-L, pentagonal, bipyramidal, bipyramidal, pentagonal, bipyramidal. Okay. That's all about today portion. So today we learn about that, one of the very important question. first volume, page number 178. What are the differences between crystalline solid and amorphous solid? It's a very, very important question. So today I am giving this assignment. Please all of you write the assignment. Many of them are writing the assignment. Try to learn and write, my dear children. Crystalline solid. What are the differences between crystalline solid and amorphous solid? Okay, thank you all of you. Thank you. Have a nice day.